So then sometimes we get vector equations of lines written in sort of a third form. And this is what happens in this equation. They've given us the x-coordinate and the y-coordinate. Can you see that you could break this up to being 3, 5 as a first vector, plus the scalar t times by 2 and negative 5? So we know that 3, 5 is on that line, and that this, right, whatever is here is always your direction vector. So this vector always goes 2 to the right and then 5 down. 2 to the right and then 5 down. So it's important that you know which is the direction vector, right? Our direction vector, which is we often write as b, is 2, negative 5. The length of that direction vector, 2 squared plus negative 5 squared, is square root of 29. We want to find a unit vector. You can always find a unit vector by taking any vector and dividing by its length so that you make it a length of 1. So the unit vector it's like a very, very tiny, tiny one. Oh, no space whatsoever. I am sorry about that. So the unit vector would be 1 over root 29 of 2 and negative 5. You're multiplying by that fraction. And this seems like it's nicer than I was in the past because it just asks for the Cartesian form and not the parametric form. But you have to write out the parametric form before you can get to the Cartesian form anyways, so I'm not sure if it is any better. Parametric says look at your x-coordinate. Your x-coordinate was 3 plus 2t. Your y-coordinate is 5 minus 5t. Both of these you could solve for t. First one would be x minus 3 all divided by 2, and the second one would be y minus 5 divided by negative 5. So then for our Cartesian, we have t equal to both fractions. We can just equate them. And then here, if you multiply both sides by negative 5 and multiply both sides by 2, you will get negative 5x plus 15 equals 2y minus 10. So 2y will equal negative 5x plus 25. And y would be negative 5 over 2x plus 25 over 2 if you wanted to write it in y equals mx plus b form. And so the vector equation of the line is nicer. Two lines, L and M, have vector equations. So we have a little L there and a little m just to differentiate between the two. And this question reminds me of a professor that I had in university, Professor Padmanabhan. And he was from India, and he had the greatest accent. He had once He had the lines M and N, but he pronounced them yem and yen. And so he said the lines yem and yen intersect at the point P, and it was just like such a good accent. And we had, so imagine this classroom. You know how it's longer than it is, I mean, it's wider than it is long, okay? So my university class with him was like 3 of these classrooms put together, but the front was the narrow part, and it was just super long. And so Professor Padmanabhan, he talked so quietly. And I remember the first class, he said, "Can everybody hear me?" And the next class, because at first class, whereas everybody's right at the back, right? Everybody's sitting far away from the front. Next class, everybody was up at the front. And he would have written all of his notes. He would like, this is how he would write his notes. His letters were so nice. He wrote everything fine. One time in class, a lawnmower went outside, just stood there shocked for a bit, and then got back to his lessons. I don't know. Most likely, Professor Padmanabhan has retired, but he was really good. So if you go to University of Manitoba and Professor Padmanabhan is still teaching, I suggest taking a class with him. Okay. So the lines L and M have these equations. What I would do, first of all, is looking at these equations. I don't like the form. Can we write it in this form? And this time our parameter is S. So can you see that with your coordinate I, you have 5 minus 4S. And with our coordinate J, you have 3 plus 1S, so this would be a 3 and this would be a 1. And with K, we just have 2S, so this would be 0 and this would be a 2. This form is much nicer. Same thing with vector, and we have to always remember the arrow over the vector. Just like plus C, I will give you on your quizzes and tests 1 freebie. But if you miss, right, in this question here, you would need this, over this one, over this. I've bolded them, but I should. Those would all have vector arrows over top of them. So our second vector, with our I coordinate, it's, and here, we have negative 3 minus 4t, so this would be minus 4. 7 minus t, so this will be 7 and a minus 1. And just a 6 would be a 6 and a 0 there, because there's no t's whatsoever. So now we have 2 vectors in 3 dimensions that apparently cross at some point. And we want to find the position vector of that common point. Okay? In 2 dimensions, when you did this in grade 10, you would get a systems of equations with 2 equations, right? Y equals mx plus b of one line, y equals mx plus b of a second line. You would substitution or elimination to try to find that intersecting point. Okay? In 3 dimensions, what we're going to do is we're going to look at the parametric equations. Okay? Parametric equations for the first one are x is equal to 5 minus 4s, y is equal to 3 plus s, and z is equal to 2s. In our second one, we've got x is equal to negative 3 minus 4t, y is equal to 7 minus t, and z is equal to 6. what each of these parametric equations allows us to do is to set up a system of equations. For example, since x is equal to 5 minus 4s and x is equal to negative 3 minus 4t, we know that 5 minus 4s has to equal negative 3 minus 4t. And we know from the second one that 3 plus s has to equal 7 minus t. And we know from the third one that 2s has to equal 6. One of these variables is easier to solve for than the other one. Oh, so close. But luckily, just today, I give you one more guess.
7.
Yes, you can solve for the 6.
That's 2s.
And right here, this tells us that s has to be 3. Now, there you will get questions that aren't this easy. You will get questions where the third one is another system of equations. So then what you have to do is you have to choose 2 out of the 3 and solve for s and t, and then verify that it still works in the first one. You could if you want. No, you could use matrices to solve a system of equations because we have that skill, or you could use your previous. Obviously, in this one, I wouldn't use matrices because s is easy. No, I wouldn't. No bonus points. Can you see that if s equals 3, if I look at this one, this side would be 6, t would equal 1. And if I look at the first one, again, it's not enough to go, oh, I think s is 3, I think t is 1. I don't have to check the last one. You have to make sure that it works for all of them, because especially in 3 dimensions, okay? It is very easy for 2 lines not to cross. Much easier for 2 lines to not cross in 3 dimensions than it is for 2 lines to not cross in 2 dimensions. In 2 dimensions, as soon as the slope is different, you're going to have lines cross. But in 3 dimensions, you can have slopes different. You can have what are called skew lines. This is very helpful when airplanes are flying, that we have less collisions. Makes for good, exciting news, right? Okay, that's kind of morbid. But if we check this last one, if you plug in s equals 3, on the left-hand side, I will get negative 7. And sure enough, t equals 1 works. So we can check each equation to make sure that it works. The other thing that we can do is we can plug in t equals 1 into our equation and s equals 3 into our equation. If you plug in t equals 1, do you see that you get the point? Negative 7, 6, 6. And if you check the equation when s is equal to 3, you would get negative 7, 6, 6. So that is another way that you can verify that your numbers work. It should, if that point is on both lines, it should work on both lines. Now, if you would take the flight pattern of different airplanes and, just for simplicity, assume they fly in perfectly straight lines, okay, you will find out that many airplanes, their flight patterns cross. But they cross at different times. That's okay, right? If I'm at the same place as another airplane, but they were there an hour earlier, right? I'm okay. So in this question, we had two variables because one had an S, the other one had a time. In a lot of application questions, you have the same variable time because time is a reference point 1 hour from a certain time.
That this T could be for time and that S could be for displacement?
No, S is not displacement. No. Now, anytime you're trying to find an angle between two lines, we have both cos theta in a dot product formula, and we have sine theta in a cross product formula. It will always be best to use the cos theta one, because it will tell us if it's either acute between 0 and 90 degrees or obtuse. So in this case, if I say find the angle between, I would say, okay, cos of theta is u dot v over the length of u times the length of v. That's our formula for the dot product rearranged. Now we want to find the angle between them. And here's the interesting thing. When we look back at our equations, we have more than one vector listed here. We have vector equations for both of them. And in each vector equation, there's two vectors listed. And we also found in part A their point of intersection. So what we know is that line L and line M, they do intersect. And there's an angle in between them. But which vectors do we use for u and for v? The correct ones. That is always the best answer. Yes. It doesn't matter is not the correct answer in this case. If you use the wrong vectors, yes, correct. No, not correct. Yeah. Whew. If you use the wrong vectors, you will get the wrong answer. So we need to use the correct vectors. Which vectors do we want to use? We need to use the direction vectors triple factorial. Oh, the order won't matter because the dot product doesn't matter the order. Okay? So we need to use, what are our direction vectors? For the first one, it's -4, 1, 2. Because the direction vector is this. The first vector is some, here's the origin. The first vector is some position vector from the origin. It's not the direction that that vector is going. Does that make sense? So we need to use -4, 1, 2, and from the second line, the direction vector is -4, -1, 0. Remember, the dot product means multiply corresponding elements and add them up. So you would get 16 plus a -1 plus 0 is 15. The length is just a squared plus b squared equals c squared. No, sorry, a squared plus b squared plus c squared because we're in 3 dimensions. So 16 plus 1 plus 4, 21. And 16 plus 1 plus 0, 17. We can now go to our calculator and do cos inverse of 15 over. Does anybody know that we're typing this into your calculator, make one square root sign and just multiply inside? That's the same. It's a lot easier. Well, not a lot easier, but just is easier than retyping the whole thing. Only if you're bad at typing, which, if you would have watched my keystrokes on this, would have been verified. I somehow managed to put 2 brackets in the wrong place and add tan. Not sure what went wrong there. But you get 37.45 degrees as the angle in between those 2 lines. Now, this question here is a very typical vector equation of line question. You'll see one like this on your quiz. You'll see one like this on your test. You have 2 lines. You want to find out where they intersect, which forces you to use the parametric equations, get a systems of equations, solve a systems of equations, verify that your points actually work. Okay, because I could give you one where it works for the first 2, but not the 3rd point. Then they would not intersect. And then finding the angle in between them. Yes?
Should we always use degrees, or should we use radians?
No, degrees or radians. Yes. So I'll end our video here.